Okay, ladies and gentlemen, we're talking about lesson 4 from chapter 12 today. It is permutations and combinations, all those fun things that every statistician loves to talk about. All right, these are warm-up problems from yesterday's types of work. If you'd like to do them, go for it. If you don't, don't. The last time I used something similar to this would be in chapter 0, if you even did that with Miss McKissick. I do not know. Would be the fundamental counting principle. But we're going to be talking about how to use permutations and how to use combinations. So, of course, those are going to be our vocabulary words. Make sure you jot these things down into your notes so that you can, again, understand what these words mean when we use them during class and this video. All right, here's our first example. It says that this dude named Shaq has a 4-digit passcode to access his email account, kind of like your guys' iPads. The code is made up of the even digits 2, 4, 6, and 8. Each digit can be used only once. How many different passcodes can he have? So our job is to come up with a system to figure out how to solve these. So if he can use each one of these numbers just once, I could have a 2, 4, 6, 8 would be one combination or one way of writing it. I could have a 2, 4, 8, 6. I could have a 2, 4, 2, 6, 4, 8. And I could have a 2, 8, 6, 4. As you can see, I'm going to be writing down a bunch of different things here. If you're noticing that I'm going to end up with all these numbers here, I'm going to have a bunch of different possibilities. The easiest way is to take, well, there's 4 numbers, and I can put them into different groupings. And each time I group them, they're going to be one less grouping than the other. So I'm going to multiply those 4 things, and then by 3 things, and then by 2 things, and then by 1 to get my answer of how many different passcodes. So 4 times 3 is 12, 12 times 2 is 24. I would have written down 24 different passcodes that this Shaquille could have had for his email account. That process is actually called using a factorial, and you're going to do the same thing here. So we have Jamie, Shauna, Otis, Abigail, and Ernesto lining up to take a picture. How many different ways can they line up? Well, there's 1, 2, 3, 4, 5 of them. So that's 5 times 4 times 3 times 2 times 1, which is the same thing as me writing 5 factorial. And if I do this math, I get the answer of D. Any questions with that stuff? I didn't hear you, so there must not be questions. Let's keep moving on. So that symbol that I just wrote, that exclamation point, is a factorial. That just means that I'm going to be multiplying each number by, so if it was 10, it'd be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And I can't go 0 because 0 times everything makes it 0. So we don't use a 0. Notice here where it says 0 factorial is a 1. We also have a permutation formula. The n will be the number of objects possible, and r will be the number of things taken. You got to plug it into the formula to find the quotient of these things. So make sure to write that down. Here will be our first permutation example. Remember that we have that formula. There is a 5-digit registration code, and there are 1, 2, 3, 4, 5, 6, 7 numbers here. So we're going to find out how many different registration codes are possible. Remember, a permutation, the order matters. That's why we have a registration code. So we plug in for n is 7 because that's the number of possible choices, and r is a 5. So when we do the math, we find out that we have n are 7 factorial divided by 2 factorial, which means I have 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 2 times 1, which means this 2 and that 2 cancel out. that 1 and that 1 cancel out. So the only math left to do is 7 times 6 times 5 times 4 times 3. And when we do that, we get the answer of 2,520 possible registration codes. Is this making sense to you guys still? Perfect, because here's your chance to show me you know how to do it on your multiple choice question. So remember where your numbers are coming from and make sure that you know what your N and your R are for this formula. New formula is a combination. A combination does not matter what the order of the numbers are. So your actual locker combination should actually be called a locker permutation because the order in which you plug those numbers in matters. So a little trivia weirdness for you there. Make sure you plug in this information on your formula into your notes. The only difference is that we are going to have a multiplied by an R factorial at the end. So here's our example. Whoopsies. So if we have 4, 5, 7, that is a total of 16. So I'm going to use that formula where I have n factorial will be my 16. And I'm going to divide by my 16 factorial minus my 12 possible students factorial, and then I'm multiplying by a r again, which was this 12 factorial. So 16 minus 12 is 4, so this becomes 16 factorial over 4 factorial times 12 factorial. Now I'm going to use the two bigger numbers to get things to cancel out. So I'm going to have my 16 times 15 times 14 times 13 times, I'm going to write just 12 factorial over 4 factorial times 12 factorial. Now I wrote 12 factorial because I know that I can cancel both of those. So that means I'm going to have right here all of this math. So in my calculator I'm doing 16 times 15 times 14 times 13 in parentheses, and then I'm going to divide that number by 4 times 3 times 2 times 1, and I get my beautiful answer of 1,820. So make sure you plug the numbers into the formula correctly. Now here's your open response to do the exact same thing. I'll even give you the formula so you don't have to try to look back to your notes. Alright folks, that's all for today.